Okay, let's break down how to do a hypothesis test when you have two independent samples, meaning when you want to compare the difference between either two population proportions or you want to compare the difference between two population means. So, what is the appropriate test? What is the appropriate test statistic? And then, if you're using your TI-84 calculator, what is the correct calculator function to perform the appropriate hypothesis test? So anytime you have two independent samples and you want to see if there's a difference between two population proportions, the parameter of interest is P1 and P2. And we want to know if the difference is statistically significant or not. So anytime the parameter is dealing with a proportion, you're always going to use a z-test. A z-test means that we're going to approximate with the normal distribution. So that means that you will use normal CDF to find probabilities, and you're going to use the inverse norm function on your calculator to calculate your critical values. The appropriate test statistic then is going to be a z-score. So the formula for calculating the z-score is this ratio where you try to see if the difference between your sample proportion, right, is large enough. So this means that we need some sample data that involves your p hat, your sample proportion for your first sample, and your p hat or your sample proportion for your second sample. We're going to calculate the difference and see how far away it is from the null hypothesis value. And then we take that numerator and we divide it by the pooled values of your sample proportion. So that's what P bar stands for, times 1 minus P bar all over the sample size of the first sample, plus P bar times 1 minus P bar all over the sample size of your second sample. So that's how you would calculate the test statistic using the formula. If you're using your TI-84 calculator, then the function that you're going to use to get your test statistic and your p-value is going to be a two proportion z-test. Okay, let's think about this. Two, because you have two independent samples. Proportion, because the parameter is dealing with a proportion, and we always approximate with a normal distribution, so we're going to do a z-test, and then test means you're performing a hypothesis test. Okay, anytime the parameter is dealing with a population mean, so for example, you want to know if there is a significant difference between two population means, then this is where you're going to use the parameter mu1 minus mu2. Typically, because we don't know the population means, it's very unusual for us to know the population standard deviation, which is sigma, for both populations. So typically, these two values are unknown. So anytime we don't know the population standard deviation sigma, we're always going to use a t-test. A t-test means that we're going to approximate our probabilities on the t-distribution. And anytime you use a t-distribution, you need to know your degrees of freedom. So the degrees of freedom here is going to be n minus 1. But because you have two independent samples, it's possible that your two samples are not of the same size. So let's say that your first sample, maybe the sample size is 25, and then the second group, the sample size is 30. So the degrees of freedom that you're going to use is always going to be the degrees of freedom using the sample size from the smaller sample of your two samples. So in that example that I just used, you would use n equals 25 instead of n equals 30 to get your degrees of freedom. So because we're doing a t-test, the test statistic is going to be a t-value, which behaves like a z-score, but on the t-distribution. So you can think of it as a t-score. We call it a t-value. And again, it also is a ratio, where in the numerator, we want to know if the difference in our sample mean is statistically significant. So this means that we need some sample data that involves x bar 1 and x bar 2. So we're going to subtract them to see if that difference is significant, see how far away it is from the null hypothesis value. And then we take that numerator and we divide it by, the denominator is going to involve the sample standard deviation for your first sample. You square it and divide it by the sample size of the first sample, plus the sample size of the second sample. You square that value and divide it by the sample size of your second sample. So notice that this formula for the test statistic, it does not involve any sigmas because you don't know sigma, it's unknown. If you're using your TI-84 calculator to get the same test statistic as well as the p-value, here you're going to use a two-sample t-test, okay? And again, you know that this will make sense because two means you're dealing with two independent samples, so two sample. T-test because we're going to approximate using the t-distribution, and test means you're doing a hypothesis test. We also learn in this unit that anytime you're testing a claim to see if there's a difference between two population parameters, you can also test the difference between those population parameters with a confidence interval. So a hypothesis test is just one way to see if there is a difference between your two population parameters, but you can also, again, use the method of building a confidence interval to make a conclusion as to whether or not there is a statistically significant difference between your two population parameters. So if your population parameter is dealing with two proportions, so we want to know what is the difference between P1 and P2, and is it statistically significant or not, you can build a confidence interval for the difference. So the confidence interval, right, for the difference, we can estimate that. You can build a certain confidence level, whether it's a 95%, 95%, 99%, 98%, or whatever, depends on your significance level alpha, and it needs to match up with the hypothesis test that you perform using that same significance level. So we learned in earlier units that the confidence interval, to get the lower confidence limit, you need your sample statistics. So here we would use p hat, so p hat 1 minus p hat 2. What is that difference? And then subtract your margin of error, which we call E. And then to get the upper confidence limit, you would need the difference in your sample proportion, so p hat 1 minus p hat 2, and then add your margin of error, which we call E. If you're using the TI-84 calculator, the function you would use here is two proportion. So again, we have two samples. We want to know if there's a difference in the two proportions. We always approximate with the normal distribution, so Z, and then INT stands for interval. So this is the function that you would use and the one that makes most sense for building a confidence interval for the difference between two population proportions. Now, if your parameter is a population mean, so if we want to know the difference between two population means, again, we can build a confidence interval to estimate that difference. So mu1 minus mu2 is going to be between some lower confidence limit and some upper confidence limit. So here, we would need some sample statistics, and the sample statistics here is going to be your sample mean, which we call x bar. So x bar 1 minus x bar 2. Let's see what that difference is in our sample. Subtract your margin of error. To get the upper confidence limit, again, we're using our sample statistics, our sample mean of x bar 1 minus x bar 2, see what that difference is, and add the margin of error. That gives you the confidence interval. Or you can use your calculator, and the function here would be 2 sample t interval. Okay, and again, this makes a lot of sense. 2 because we have two independent samples. T because we approximate with the t distribution, and interval because we want to build a confidence interval for the difference between the two means. So I hope that this helps you break down all the different tests that you've learned and which formulas you use for which situation and which calculator function to use for which situation. I hope this helps.